All right, morning. Online, can you hear me? Can I see the screen? Students online? Not hearing anybody online.
Yes, sir. We're hearing it.
And you can see the screen as well.
Yes, sir.
Yes, sir.
All right, good. All right, let's see if we can make this a very efficient session. Just want to work through the questions that I gave on the paper yesterday. Again, it's all part of the revision process, just to keep what we have learned so far since September current, as we're going on to new stuff in January. All right, so just want to ensure that they don't have too much sorrel and cake and ham and forget the stuff. Come closer to mom. Classroom kind of empty. Come. All right, so we're going to work through this paper that I gave you. Question that I gave you from it's January 2012. And I'm going to, as usual, start working from the questions at the back. All right. So I'm going to start at number 11 right here. Number 11. All right. And as usual, if you did not do the question, you need to go and do it even after I do it. Some persons did them and send them to me, which was good. But a lot of persons have not yet done it. I am just doing my job still, which is to do the revision. You have to do your part. All right. And I cannot account for persons who fail to do their part. I'm doing my part. All right. You have to do your part for this process to work. It's a teamwork and it's a team effort. Right? I do some stuff and you do some stuff to make it work. All right. Number 11, part A. Number 11, part A. So it's a vectors question, and it gives us two portion vectors, OA and OB. We can see them here. This one is the vector OA going this way. Starting, we start. And this one is the vector OB going that way. All right. And it wants us to write down those position vectors, these two position vectors and that displacement vector. All right. So for the position vectors, we can get those position vectors from the coordinates. So A, for example, on this diagram is a point -1, 3, -1, 3, -1, 3. That's a point A. And B is a point 5, 1, 5, 1. So then it means that OA right here will simply have the same values as the coordinates up here. No calculation needed for that. -1, 3. And OB again will have the same values as the coordinates of B. 5, 1. 5, 1. And then to calculate BA, since we know the portion vector of the A and the B, we can use OA minus OB. That's OT on the last minus OT on the first. And so we're doing this one minus this one. So we cannot subtract them same place. So it's a -1 minus 5, because it's this one minus this one. And so it's -1 minus 5 is -6. And then 3 minus this one is 2. We can check this on the diagram now. This means to go from B to A, we have to go 6 to the left and 2 up. That's what the vector is. To go from B to A, we are going 6 to the left and 2 up. So we can actually just check it on the diagram, make sure it is correct. So we're going from B to A, because it's BA we're finding, right? Yes. So talking about the vector up here, from B up to A this way. So based on the calculation, we're going 6 to the left, which is 1, 2, 3, 4, 5, 6 to the left. That's a -6. And 2 up. 1, 2. That's a 2. So you know the calculation is correct based on that. All right, for the vectors, the calculation and diagram must be saying the same thing at all times. All right, so that finishes that part. Next part says, given that G is the midpoint of the line AB, G is the midpoint of the line AB, write the vector BG. All right, so G is the midpoint of the line AB. So this is the line AB. So G is halfway on it. What they want us to tell them? BG. So B to G, they want this way. So B to G is going to be half of the BA. Because the G somewhere is going to be somewhere near. So it's half of the BA. All right? That's what they want, BG. So BG based on this is simply half of the BA. They didn't ask for OG yet, you know. They're asking for OG now. They want BG first, which is just half of the BA. And so it is just half of this vector, which becomes -3, 1. This means to go from B to G, you go 3 to the left and 1 up. So you go half the distance. Then they want the vector OG. All right? So now they want the vector from O to G, which is the vector from here. So we can look at the diagram and see it. We go from B to G, it is saying 3 to the left, 1, 2, 3, and 1 up. So G is right here. And that point has coordinates 2, 2. So our calculation is supposed to give us this vector OG as 2, 2. This is supposed to work out to 2, 2. But how can we work it out? Multiple ways to work it out. We really want to go from O to G. We really want to go from O to G. And we have BG. So what we can do, we can take the BG that we have and split it up to find the OG. Let's do it right here. Let me do it on this side of the screen. So we have BG, multiple ways to do it. I'm not going to tell that this is the only way. We have BG equals -3, 1. And we want to get OG out of that. So we can split it. Split it. So we take this and we want to split it into position vectors. And write it as O times the last minus O times the first, which is OG minus OB. And that is equal to -3, 1. And then make OG the subject. We're going to transpose the OB over there and make it positive. And so the OG becomes -3, 1 plus the OB, the vector OB. And the OB, we have it up here. It is 5, 1 right here. It is 5, 1. Let me just put the 5, 1 beside it. And so that OG becomes -3 plus 5 is 2. Or 1 and 1 is 2. Which is what we're supposed to get based on the diagram that just showed it. So that is it. So maybe I would give them this calculation to see how we get the point to OG. All right, so this works out to be 2, 2. That finishes that part of the question. Down here now is someone. So major C's, straight major C's. Part B and C are major C's. All right, I'm going to do those on the right side of the screen. All right, so let's go. All right, so part B says L is this matrix and M is that one. And I want us to do L plus 2M. So that's pretty straightforward. L plus 2M becomes the L matrix, which is 3, 2, 1, 4, plus 2 times this. And 2m, the 2m, based on this matrix, the 2m means that we're going to be doubling each of these values. All right. So we are back. Very good. Kind of slouchy, but let me just start this one over. I don't know where we would have cut off online. Online students, did you still can't see me, hear me? Can see the screen? Ocean?
Yes, sir.
All right, good. Right, so I was saying that we're trying to do this calculation, L plus 2m from these two vectors. So it is a L, which I have here, and I need the 2m now. So the 2m is twice this. So I'm just going to write what 2m here. What 2m is here. So it's 2 times this, which is negative 2. 2 times this 3, which is 6. 2 times this 0, which is 0. 2 times this 2, which is 4. So this is the vector 2m that we're adding over here to the L. So just going to add that over here, which is the minus 2, 6, 0, 4. And we're just consolidating the values. So the 3 minus 2 is 1. 2 and 6 is 8. 1 and 0 is 1. 8 and 8. 4 and 4 is 8. So that is the answer right there. Then it wants us to do the product ln. Multiply L times M. So we know that's a process again. L times M. So let's just do it here. So Lm will be the first matrix, which is a 3, 2, 1, 4. And the second matrix is minus 1, 3, 0, 2. Remember, when you multiply matrices, you multiply the rows of the first matrix by the columns of a second matrix. So this line across here is reminding me that I'm using these two rows. This line down here is reminding me that I'm using these two. Jackson, stop talking now. That I'm using these two columns. All right? And the resulting matrix is going to be a 2 by 2 matrix with 4 values. So this first value, because it is positioned in the first row and the first column, first row and the first column. It means that we have to use this first row and this first column to get it. And multiply a row by a column by multiplying the first element in the row by the first element in the column, and the second element in the row by the second element in the column, and you add those results. So we say it's first element times first element, second element times second element. First element times first element, second element times second element. So it's 3 times minus 1 and 2 times 0. The 3 times minus 1 is negative 3, and the 2 times 0 is 0. And so, okay, actually, let's write the first value. Let me just finish and then I write the values. Now, this second value here now is positioned in the first row and the second column. So to get it, we have to multiply this first row by this second column and multiply them the same way again. It is first element in the row by the first element in the column, second element in the row by the second element in the column. So it is first element times first element, second element times second element. That's 3 times 3 and 2 times 2. The 3 times 3 is 9, and the 2 times 2 is 4. Then the value down here is positioned in the second row and the first column. So to get it, we're multiplying this second row by this first column. And again, it is first element in the row by the first element in the column, second element in the row by the second element in the column. First element times first element, second element times second element. 1 times minus 1, 4 times 0. 1 times minus 1 is negative 1, and 4 times 0 is 0. And then this last value out here is positioned in the second row and the second column. So to get it, we multiply this second row by that second column. And again, it is first element times first element, second element times second element. First element times first element, second element times second element. 1 times 3 and 4 times 2. 1 times 3 is 3, and the 4 times 2 is 8. And then we're going to consolidate these values and get the final resulting matrix. The minus 3 and 0 here is a negative 3. The 9 and the 4 here is 13. The negative 1 and the 0 here is negative 1. The 3 and the 8 here is 11. And so that is the answer right there. Nice and easy. So these two are done. Then we come to part C. Down here. Gives us his matrix Q. And it wants us to find Q to the minus 1. That's the inverse of Q. All right. So we have the Q equals 4, 2, 1, 1. And we are trying to find Q to the minus 1, which is calculated using 1 over the determinant of the Q multiplied by the adjoint of the Q. So the determinant under here is equal to the first diagonal product minus the second diagonal product. So it's 1 over. First diagonal product is 4 times 1 is 4, minus the second diagonal product is 2 times 1 is 2, so subtracting 2. So determinant under here becomes 2. So 200 there. They're multiplying that now by the adjoint matrix of Q. And the adjoint is formed by interchanging the elements on the first diagonal, switch them around. And so that 4, 1 becomes 1, 4. And then these two other elements on the second diagonal, you leave them where they are, but you change the signs. So this 2 changes sign to a negative 2. And this 1 changes sign to a negative 1. And so the final result now can be obtained by dividing each of these values by this determinant of 2. So 1 divided by 2 is 1 over 2 or half. Negative 2 divided by 2 becomes negative 1. And negative 1 divided by 2 is negative half. And 4 divided by this 2 is 2. And so this is your Q to the minus 1. the inverse matrix. That finishes that. And this part now says, using a matrix method, find the values of x and y on this equation. So this requires a basic matrices transposition. I must observe that this matrix right here is actually your Q. Mute your mic, please. Alyssa, mute your mic. It's actually a Q. All right? So the equation that we actually have here, this equation right here, it is actually Q times XY. Let me put over here. It is actually Q times XY equals 8, 3. And basic matrix transposition of this form tells us that the inverse of this matrix, when transposed onto this side, it goes to the front as the inverse. We leave the XQ, the XY as a subject. And so the XY is going to be equal to Q to the minus 1. That's to go in front. Since it's on the front on this side, the inverse must go in front on the right side. And so you put the inverse in front of the 8, 3 and do this calculation to see what the X and the Y values are. So the inverse matrix that we calculated a while ago was this one. And these are easy numbers to work with. So this time we can work with the halves, right? And those are easy numbers to work with. Normally I would say work with this one and leave the half outside for last. But now I'm going to use this one here. So I'm just copy it down. Wrong thing I press. This is the Q to the minus 1. I'm multiplying that with the 8, 3. All right, so we're going to multiply this now. I'll multiply this, going to get a column vector. Column vector with 2 values. Again, using the rows of the first matrix by the 1 column. So the first element here, first row, 1 column. So to get it to multiply this first row by the 1 column. First element times first element, second element times second element, just the same. So it is half times 4, half times 8, and minus 1 times 3. The half times 8 is 4. The minus 1 times 3 is negative 3. And this value here is positioned in the second row, 1 column. So using this second row and this 1 column to get it. So it's first element times the first element, second element times second element. And so it becomes negative half times 4, which is negative 4, and 2 times 3 is 6. And this is your XY that you're calculating, XY. So the final result is that XY is equal to the 4 minus 3 here is 1. The same as 6 minus 4 is 2. But don't leave this as the answer, and that's not the answer. The answer is when you state the value of X and the value of Y. So you have to say the X is equal to 1 and the Y is equal to 2. And you present this as your answer to the question. That is it. Very good. I will ask like you want to sleep. Huh? You tired? Here, it's work you out. You're painting house. Huh? Oh Lord. That's what it is. All right. So that one question down. How many I give you? I give you about 7 to the done. Good amount of question to do for the paper. About 6, yeah. So we're at a good place if I can be giving you so many questions to do in December. Because it means that we would have covered all of those things, right? I know we don't do this yet. This is more tricks. But yeah, we can do question 9 for sure. All right? Question 9. All right. So question 9 gives us this. It said make X the subject of this formula. So it's almost like the formula inverse for us now. Make X the subject of this formula. Transpose to make X the subject. All right. So we have the Y equals 2X plus 3 over x minus 4. I see you ask us for the inverse subsequently. This is a method some people use to find inverse, you know. The transpose made the x subject first, then they do the inverse. Some people do it that way. You understand? Some people transpose made the x subject first, and then now they do the inverse, interchange x and y, and that's the result. Some people approach it that way. So this question kind of forcing us to do it, use that method. But anyway, take it, still have to transpose to make whatever is in this position the subject, whichever method you use. All right? So to make this x the subject, we need to expand it out into separate terms. So we can group the terms in x on one side. So the first thing to do is to take this denominator and multiply it across here by this y. And so it's going to become the y times x, which is yx or xy if you like. And then y times negative 4 is negative 4y. All right, we can call this yx still, no matter. Same thing. And it leaves us with this, 2x plus 3. Because you're trying to make x a subject, you want to get this 2x over onto this side. You're going to move this minus 4y over onto that side. That's the transposition we're making. And change the sign when you move them. So this yx remains. This 2x comes over here, becomes a minus 2x. Equals this 3 remains there, 3. This minus 4y goes over and becomes a positive 4y. Then to make x a subject, now to factorize the x out of these two terms, let's do it. So factorize x out of it, and get y minus 2. And factorize x out of this, still equals 3 plus 4y. There's a matter of taking this y minus 2 and divide it under this side. Same as saying divide both sides by y minus 2. So the x is going to be 3 plus 4y over y minus 2. That is it. We have made x the subject. And then this part now says, hence, determine the inverse. So the inverse is just going to be this, you know. Just that you make yx and you make xy. Right? Simple, because you have already done the transposition that we'll do for the inverse anyway. All right? So you can literally just write it down. So for part 2, all right, since f to the minus 1 is this expression, f to the minus 1 of x equals 2x plus 3 over x minus 4, it implies that the f to the minus 1 of x is just the same expression we have x where the y is. Because if you have this and you're trying to form the inverse, you turn this into y and turn these into x's, which is the inverse, right? So you basically just write in this back and put x in those places where the y is. So it becomes 3 plus 4x over x minus 2. That is the inverse. So no calculation needed for that. All right, for part 2. Then this part now says, find the value of x, for which f of x is 0. That's simple enough. If a function equals 0, then the numerator equals 0. Simple as that. All right, so for part 3, f of x equals 0, meaning that 2x plus 3 over x minus 4 is equal to 0. So imagine if you take this denominator and multiply it across here by the 0. Then you're going to end up with the numerator equals 0. But that is something to know. If a fraction equals 0, then the numerator must be 0. Simple as that. If a fraction equals 0, the numerator must be 0. Right? So the 2x plus 3 has to be 0. And so the x has to be negative 3 over 2. What can I say that? So you cover the 3 first and make it negative, and then divide another 2. That is it. Easy question. That one done. Not complicated. So this one is kind of a linear programming question now, but they give us the graph and the shaded region and everything. All right. It says the diagram below shows the graph of 3 lines and the shaded region defined by 3 inequalities associated with the 3 lines. It said the inequalities associated with the lines, with the line 3y equals x is this. So this line is 3y equals x. And the inequality associated with it is this one. Why is that? Because the shaded region is actually above this line. That's what it's basically telling us. All right, so they're helping us, they give us that information. I guess I wanted to write down the other inequalities. See, state the two other inequalities defined in the shaded region. So the shaded region is bounded by this line, but they gave us that inequality already. The other two lines are this one and this one. That's x equals 6 and x plus y equals 40. So the shaded region is above, look at it, above solid line x equals 6. That inequality is therefore x greater than or equal to 6. That's the first one. The second one, the shaded region is below x plus y equals 10. Below a solid line. And that solid line is x plus y equals 10. So that inequality below is less than. When y is positive, less than means below. So it's x plus y less than or equal to 10. So these are the two other inequalities. This one and that one associated with that shaded region. But understand that? Those are two inequalities. All right, what does I want us to do? It says the function p is 4x plus 3y might be profit. It says it satisfies the solution set by the closed region, closed triangular region. In other words, this function works in the shaded region and also along the line, right? It says identify the three pairs of x and y for which p is maximum and or minimum. So it's at the vertices. So we have to go to the vertices to get those three pairs of values, as we know. So let's name them. Let's name this one A. Let's name this one B. Let's name this one C. So we're going to have to read the scale properly, right? So on this horizontal axis, every one of these little millimeter line is 1. So this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? All right, so this point, therefore, is at 2. Y value is 2, x value is 6. So A is a point, 6, 2. What can I say that? And then B now, B is 6 what? So this is 30. This is, let's look at it properly. This point right here is 34. 30, 31, 32, 33, 34. So 6, 34, that one. So B is a point, 6, 34. And then C out here now is what? 30, 10. 30, 10. So C is a point, 30, 10. Want to go to that? All right. All right, so those are the 3 points at the vertices. Then it says now, which pair will make P maximum? Justify your answer. To justify your answer, you have to do the little test. That's why you justify your answer. You can't just state which one it is. You have to do the test to justify your answer. See? In bold letters, justify your answer. So you cannot just look and know. So you say, which pair will make P maximum? So you're going to test for maximum P. All right? So let's go. So the P formula is 4x plus 3y. So which point will make it maximum? Either the B or the C, don't it? The A out of it, right? So we're going to test for maximum P. Test for maximum P. We're going to test the point B first, which is 634. The P at B would be equal to 4 times 6, yes? Plus 3 times the Y value is 34. Somebody write this out for me. And let's test the C. At C, which is 30, 10, The P at C will be 4 times the 10, 4 times the X value, plus 3 times, no, not 10, 3 times the 4 times the 30. X value is 30. 4 times 30 plus 3 times 10. What does one work out to? How much? 120? 126? And this one is what? 120 plus 30. Second one, 150. 150. So that's where you get the maximum, right? Good. So you have justified the answer by doing that test. You're going to say P is maximum at the point C 30, 10. All right, that is it. And this is your test for maximum P. So this would have justified the answer. That is it. That finishes that question. Done. 2 down, about 5 to go. Very good? All right, beautiful. All right, that's number 9. So I know we're not doing number 8. Number 8 is a pattern question. We'll do a close exam. This is statistics. We're going to do this in about March, statistics. About March, we're going to be doing statistics. No, about early March, end of February, March. We can do this one, number 6. Number 6 is a quadratic question. All right. So number 6 gives us this quadratic function over this range of values. So you see from -2 to 4. That's what this means. From x value -2 to 4 That's a domain. And these are the y values. And I want us to complete these 2 cells, I'm sure. And you can look at the symmetry of the values and complete it, you know. So look at it now. You have a 5 here and a 5 here. Inward from this 5, you go to a 0. So inward from this 5, you must go to a 0 too. Then after this 0, go to a -3. So after this 0, must go to a -3 as well. Remember, the values are symmetrical. Right? Once these x values are equal intervals apart, because of the symmetric nature of the quadratic function, the values are going to be symmetrical about a line of symmetry. The line of symmetry is basically somewhere in between here. No, not there. So you want where the values become the same. Oh, so it's not shown on this. So this might be that might be the minimum. This might actually be the minimum. The minimum might actually be at 1, -4 based on this right here, because the values are symmetrical about this right here. See, notice the values are symmetrical about that. So that might be the axis of symmetry, right? Where x equals 1. That might be axis of symmetry, or your symmetry. So the 1, -4 should be a minimum point, but we can test it still, right? So the line of symmetry is right here. And the values are symmetrical that way and that way about that line. So the line of symmetry is where x equals 1. But let's see it though. It says to complete the table. So those values I put in by observation, by looking at the symmetry of the value, can actually be calculated. So how would you calculate this 0, for example? By putting the -1 in the function to see what it works out to. So the function is y equals x squared minus 2x minus 3 at x equal -1 right here. You can check it, it works out to 0. The y becomes -1 squared minus 2 times -1 minus 3. So this -1 squared becomes a +1. This -2 times -1 becomes a +2 minus this 3. And so you see you get 0. You get 0. We could know 0 by the symmetry. And then now we can test if this is actually -3. So we're going to put in x equals 2 in that one now. So the y is going to be 2 squared right here. 2 squared minus 2 times 2 minus 3. This is 4 minus this is 4 minus 3. These two wipe out each other. 4 minus 4 is 0. This is -3. So see, they will get -3. So you know that the answers are correct by its own way. So I did it by observation, but then I did it by calculation just to check. All right. So I've completed the table. Next part says, using a scale of 2 centimeters. So this want us to draw a graph. But I'm just going to sketch it, right? I'm just going to sketch it. So 2 centimeters, 1 unit on the x-axis, 1 centimeter, 1 unit on the y-axis. Plot the points are recorded in the table and draw the smooth curve. So the quadratic curve they want us to draw. So drawing is you have to do it accurately on graph paper. But I'm just going to sketch it over here. All right, I'm just going to sketch it over here. So the highest value based on this is 5. The lowest value is -4. All right, so let me put the x-axis right here. And I'm going to start at -2, -1, 0, 1, 2, 3, 4. Let me do it that way. And then zoom it up. Zoom it up. The x-axis here. And the y-axis come through the origin here, so now. We're going up to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then going down to -4. 1, 2, 3, 4. -1, -2, -3, -4. Let's put the points in red. So the first point is -2, 5. -2, 5. -2, 5 is up here. So it's up here, -2, 5. Then -1, 0, that's on the x-axis right here. -1, 0 is on the x-axis. Then 0, -3 is the y-axis intercept right here. 0, -3. Then 1, -4, 1, -4. I think this is a turning point. Yes, it is a turning point right here. Then 2, -3. 2, -3 is right here. Then 3, 0 is again on the x-axis right here. And then 4, 5. 4, 5, 4, 5 is up here. In line with this one. So about here. Let's draw a smooth curve through those points. That's it. Simple as that. But you have to do it on graph paper. All right. Next part now says, using your graph, estimate the value of y when x is 3.5. Now, it says show on your graph how you would obtain it. So when x equals 3.5, all you need to do is find 3.5 on the x-axis and see what the y value is. So 3.5 is right between the 3 and the 4 here. So right here's 3.5. Find the y value, come up on the graph, and read across. Looks like 2 point something based on this stuff. But because I have the formula, I can check it by putting the 2.5 in the function to see what it actually is. So I would do my little check on the side, not on the exam paper. I do it on the side because the question said you have to use the graph. But I would check to see what my calculation gives me. So at x equals 3.5, y is equal to 3.5 squared minus 2 times 3.5 minus 3. So I would do that check, right? Let me see what the calculator is giving me. I'm just working it here. So 3.5 squared minus 2 times 3.5 is 7, and then minus 3 more, so subtracting 10. So subtract 10. Yeah, 2.25. 2.25. So what I'm getting. Some of that. I might give them 2.3 on the actual graph paper. But on graph paper, I might actually get it. So let's say estimate. So I would say y equals 2.3. But the actual value is 2.25. But I wouldn't give them a 2.25. I'll give them what the graph gives me. So if you get the question, say estimate, estimate. So more than likely, a graph might give you 2.3 rather than give you precisely 2.25. I might give you 2.2. So I might give you 2.2 or 2.3, depending on how you're drawing your graph. But not nobody going to draw this line segment exact same place. You get me? But that is how you do it. That finishes that. All right. Next part now says, without calculation, right? Write the equation of the axis of symmetry. That's the line up here, the one. Let's do it in black. The line through the turning point, which is 1, -4. Axis of symmetry is x equals the xt value, which is 1. So this is x equals 1. Estimate the minimum value. The minimum value is the lowest y value in the graph. That's without calculating. I would say it is y equal -4. And then I can check it as well, make sure, by completing the square. Right? And then that's us. Without calculation, then you must get from the graph. State the values of x for the solution. This. So we're talking about, well, this one kind of easy because they were in the equation here. So it's -1 and 3 right here. -1 and 3. So it should be -1 and 3. X equals -1, x equals 3. So this one kind of straightforward. But go to that. Yeah. All right. Yeah. Symmetrical. The values are symmetrical. All right. So look at it again. All right. So the values will always be equal on either side of the axis of symmetry. So that way, axis of symmetry is usually somewhere in the middle there. The values are the same going out from the axis of symmetry. I can look another way and say the values are the same coming in towards the axis of symmetry. So coming towards each other from outward in, the values are the same. I can look at it the other way, from in out, the values are the same. Get me? Good. Because of the symmetric nature of the graph. The first thing that jumps out at me is the 5 and the 5 here. So okay, good. I can work my way in from this 5 and 5. The values must be the same. But the key thing to ensure is that your x values are changing by the same amount for those x and y values to be symmetrical. X values must be on the same interval. Understand? Good. So because I have the 5 and the 5 as a guide to help me, I know that coming inward from the 5 this way and coming inward from this 5 this way, the values must be the same at each interval. So right after this 5, coming inwards, I get this 0. So coming in from this 5, this must be a 0 too. See that? Then now, coming from the 0 now, inwards still, because now I have a 0 here and a 0 here. Coming inward from this 0 and reach -3. So coming inward from this 0, I must be -3 as well. See that? Good. And then now, these two values, see let me show you something now. It's because I have these two values here, so now, same y value, the axis of symmetry must be halfway. The axis of symmetry must be halfway between this 0 and this 2. Because the 0 give me this, give me the same y value. The 0 give me -2, -3, and the 2 give me -3. So the axis of symmetry must be halfway between the 0 and the 2. Halfway between 0 and 2 is 1. I'll put another way as well. You could say, remember, the axis of symmetry is always the average of the two roots. But what are the two roots? No, this is -3. All right, so watch this now. Another way you can look at it. These are the two roots, you know, where the y value is 0. So these are your two roots. These two x values are your two roots. The roots are the points where the y value is 0 on the x-axis. Good. So those are your two roots on the function that -1 and that 3. The axis of symmetry is the average of your root values. That's another way to know your axis of symmetry. It's the average of your root values. Okay, two roots are going to be equidistant from the axis. So you identify your two roots, the axis of symmetry is halfway between them. So if I average this -1, average them, -1 plus 3 over 2, it's going to work out to be 1. So it means that xt is the average of the two roots. Right? So I'm going to work it out. So I know that the root, the axis of symmetry is right here. Right there. You get me? We could see it from a symmetrical nature of the values as well. Right? Because these two end up to be the same. So the axis must be equidistant between them, and either side must be on this line right here, where x equals 1. Right here is the axis. Right here is the axis. So the axis pass through the turning point. So this must be the turning point, 1, -4. All right. So that's from experience and from working a lot of questions, but I'm giving all of that knowledge. All right. That finishes that question, guys. Very good online. Tend to forget people online when I'm in class, you know. Very good online. They're still there. Hello? When is it gone? Oh, they're still there. All right, I see a thumbs up. I hope that means everything all right. All right, let's go on to the next question. Some of the people who should be here, they're not here, they're online looking. Oh, you mean that unfair? You learn better face-to-face every time. Online don't work. Online is like 50%. Tell you, I don't like it. I don't like online at all. I just do it because we don't have another choice. I have to keep practicing. So, all right, let's go. Number 5. Let's do number 5. So number 5 has some stuff in it that we don't really cover yet. All right. I want to know the plane and solid geometry, the plane geometry, but we can tell you some of this. This question says the diagram below, not drawn to scale, shows two triangles, JKL, which is this one, and MLP, which is this one, with JK parallel to ML. That's why they have these two arrows on here. These two arrows on here, those two lines parallel. And then they give us some equal size. LM equal MP, but they don't put that on the diagram. So I'm going to put some lines on it. So it says LM, which is this one, is equal to MP. So that's an isosceles triangle. Let's put markings on it to remind us that they are equal. I'll put a little mark on this, a little mark on that. It means that those two sides are equal in length. Then it says KLP is a straight line. This is a straight line across here. Good. What I'm doing is I'm reading up here, I'm reading information up here, and checking if everything that they have said in there is on the diagram. Once everything that they have said in there is in the diagram, it means that I don't need to go back and read up here to do the question. I cannot look at the diagram for the information that I want. So because they didn't show these marks and these two lines to say that they are equal in length, I put them on there to remind me that these two sides are equal in length. And so this is an isosceles triangle. And then it tells us that this angle is 22, that's shown on the diagram as well. And this angle is 36, is shown on the diagram there. So everything you know is on the diagram. You can work from the diagram. Remember now, we don't do this yet, still not bad, but Z angle, right? We have parallel lines. You have parallel lines like you have here. You have some angles that are known angles that are formed where you have parallel lines. When parallel lines are connected with another line, that other line is called a transversal line. So in this case, this is one transversal line, and this is another transversal line. So you have what we call alternate angles or Z angles when you have parallel lines. So if you join these with these, if you join this transversal line here, they're like you're forming out a Z, which is down here, up here, and down here. So the angles in the Z are equal. So these two angles here will be equal. Call them alternate angles. They are equal. Right? Another thing I can get when you have parallel lines, joined by a transversal line, and I'm using this one this time, is what we call co-interior angles. Those co-interior angles now I'm talking about would be, show them in red, would be this one and this one. I sometimes call them U angles because they appear to be angles inside of a U. So the parallel lines here, so when joined at the base down here, it's like you're forming out a U. So I call them U angles. The total of the angles inside the U is 180 degrees. But the proper name for them is that they are co-interior angles and they are supplementary, meaning that they add up to 180 degrees. So these two angles in here, they are co-interior, them add up to 180 degrees. All right, the angles in this U. But you must have parallel lines for you to have co-interior angles. You must have parallel lines for you to have alternate angles. All right, good. Also, we have parallel lines, you can have what we call corresponding angles. We'll give an example now. Corresponding angles. So, but take this now and I draw this line straight out here and extend it across. These two parallel lines will relate or will interact or will cross this line at the same angle. So this angle down here is the same as this angle down here. Understand that? They are called corresponding angles. Similarly, this angle over here is the same as this angle over there. So this horizontal line crossing both lines will interact with those two parallel lines the same way in terms of the angles. And those are called corresponding angles. So we have parallel lines that are joined by other lines, which are called transversal lines. You have alternate angles, which we call Z angles. Z angles are equal. You have co-interior angles. After the angles seem to be inside of a U. So if you take the parallel lines and join them with a line and set it up like a U, the angles inside the U are called co-interior angles. And those angles add up to 180 degrees. And then now, if you cross two parallel lines with a straight line across, that line is called a transversal line. Corresponding angles are equal, because the two lines will form the same angle with that straight line. Those are called corresponding angles. So those are the things you're looking out for when you have parallel lines. We're going to deal with this again. We'll do some more trigonometry. All right. So don't worry about it. This will be revisited properly in the proper way when we do trigonometry. In particular, when we're doing sine rule and cosine rule. Right? Because we have to use some of that. So it's actually coming very early in January. All right. So they want the angle MLP. Where is that? MLP. MLP. That's this angle down here. So this question is asking us for this angle down here. Let me use that blue ink. So this question is asking us for this angle. Angle between M, L to P. M to L to P. Now that angle that are marked blue and this angle here, they are equal. Why are they equal? Because this is an isosceles triangle. Because these two sides are equal, the angle opposite to this side is the same as the angle opposite to that side. That's how triangles work. All right? An angle and a side opposite are related to each other. You know? So because this side in triangle is equal to this side in triangle, then the angle opposite to this side, which is over here, is equal to the angle opposite to this side, which is over here. But some people just say, boy, the base angles are equal, but you don't have to look like a base angle. That's why I prefer to say the angles opposite the sides that have equal length are equal angles. And then now, because the total angle in the triangle here is 180, and these two equal, then we can find them. I like to say, if you know one angle in an isosceles triangle, you are blessed, because you can find the rest of them easily. If you only know one in an isosceles triangle, because two of them equal. So because these two equal now, if we call them alpha for the time being, It means that 2 alpha plus the 36 degrees is equal to 180 degrees. So the alpha is going to be subtract the 180 and then divide by the 2. 180 degrees minus 36 divided by 2. That becomes 90 minus 18 if you divide each of them by the 2. I can just work this out first and then divide by 2. Either way. You can divide this by 2 first and get 90. Divide this by 2 and get 18. And 90 minus 18 is how much? Minus 10 first, you get 80, minus you get 72. So each of those angles is 72. So this angle is 72 degrees. What I go to that calculation right there? Good. Isosceles triangle. Let me put on the angles in there. So as I find them, you put them on. So this inside is 72 degrees. This one is 72 as well. All right, so we have those two angles. The next angle I want us to find is angle LGK. 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 That's this angle up here. Now that angle is alternate to the 22 down here. See that? So they are equal. They are alternate angles. So these two angles equal. They are alternate angles. They are angles in the Z. Right? So those two angles are equal. So this angle up here that I want is also 22 degrees. Alternate angles are Z angles. They are equal, right? That's why those are equal. And for this one, because we're an isosceles triangle, right? For the question said, given reasons, and I see it here, given reasons. So this one is 72 because the triangle isosceles. MLP is isosceles. It have two equal angles in it. And then this one is because of the alternate Z angles, which are equal. All right, let's put them on now. So this angle up here is 22 degrees. This one is 22. All right. Next angle I want is JKL. Where's that? JKL. That's this one right here. That is 72, you know. I know that is 72. Okay, it is corresponding with this one. Mark that different color. JKL is 72. So this line and this line parallel. So this angle and this angle equal, joining with this straight line. So these two angles are equal. So this is 72 degrees, corresponding angles. So this angle is 72 inside here, 72 degrees. 72 degrees. Same as this one over here, corresponding angles. This one is 72 degrees. Corresponding angles. All right, but it's equal to this one. Those two angles are the same. And then the next angle I want now is KJL. KJL. KLG, sorry. KLG. That is KLG. That's this angle right here. Now this one can be found using total angle in this triangle is 180. Right? So look on 180 minus the sum of these two. Or we can say total angle on the straight line is 180. Same thing. 72 and 22 from 180. Anyway, take it. It is 180 minus the sum of these two. Whether you want the triangle or you want to use total angle on the straight line. All right, so that is it. So this angle is going to be 180 degrees minus the 22 degrees and the 72 degrees. Right? What they want is the straight line or the triangle. Total angle in the triangle or total angle on the straight line is 180. Whichever way you do it, result is the same. So it's 180 minus 22 and minus 72. That is 86 degrees. Total angle on a straight line, you want is a straight line to explain it, or total angle in this triangle is 180. Whichever way is the same angles we're dealing with, same values. All right, let's go to the transformation. So this one gives us this diagram of triangle PQR and an image P prime, Q prime, R prime. So this one look up to this one, right? Looks like a reflection. All right. Let me check if it's a reflection. PQR. PQR on the object is this way. PQR on the image is the other way. So yes, it's a reflection because the orientation is reversed. Once the orientation reversed, you know you have a reflection. And the mirror line is the x-axis because the equidistant between these 2 points, which is here, and equidistant between these 2 points, which is here. So the x-axis is the mirror line. So the reflection in the x-axis. So this is the mirror line. And the line is y equals 0. All right, question says, state the coordinates of P and Q. P and Q. So P is a point 2, 1. P is 2, 1. And Q right here is 4, 3. See, 2, 3, 4. Right, so the y value up here is 3. Right here is 3, where the Q is. So it's 4, 3. Q is 4, 3. 4 out here, 3 out. 4, 3. It said describe full transformation that maps this one onto that one. Reflection in the line y equals 0, or reflection in the x-axis. Simple as that. Reflection in the x-axis. Instead of x-axis, you could say line y equals 0. X-axis, the line y equals 0. Done. That's why you discover reflection, but it's given the name reflection and the mirror line. Reflection only has one component. It says write down the coordinates of P and Q under this translation. Right? 3, -6. 3, -6 means 3 to the right and 6 down. 3 to the right and 6 down. You can actually just construct a diagram and write it down. Because I'm saying write down, see? You don't need to show no calculation. So let's go. P and Q, that's these two. Let's do P first. This means 3 to the right, 6 down. 3 to the right, 6 down we're doing. 3 to the right, 6 down. All right, let's do P first. 3 to the right. 1, 2, 3 to the right, 6 down. 1, 2, 3, 4. We can't dip on the graph. 5, 6. The one under here. So it will be 5. This is -1, -2, -3, -4, -5. So a point down here would be 5, -5. 5, -5. So P prime will be 5, -5. I'm going to calculate it afterwards just to make sure. And then Q. Let's call him double prime. Q double prime. We'll move this other one now. 3 to the right and 6 down. Is 6 down, Robin? Let me see. Let me make sure. 6 down. Yeah, 6 down will take us on to -5. Yes. This one now. 3 to the right. 1, 2, 3, 6 down. 1, 2, 3, 4, 5, 6. This point. This point is 7, -3. So Q will be 7, -3. Well, let's calculate. Let's use a calculation method. So applying the translation. So the P plus the translation will be equal to that P double prime point. The P is 2, 1. And you're adding translation of 3, -6. It's going to be this plus that is 5. And 1 minus 6 is -5. So you see it? Get the same value that we did by construction over here. So based on that, the P double prime will be 5, -5. Then same thing for the Q. The Q plus T would be Q double prime. The Q on this diagram is 4, 3. Plus the translation is 3, -6 equals. This and this is 7 and 3 and -6 give me -3. See, 3, -3 as we got here. See there? 3, -3. 7, -3, sorry. So Q double prime will be 7, -3. So we did it by calculation and we did it by the graph. Answer the C. That finishes that question, guys. Nice and easy. Body good? Online, body good? Oh, nobody no good. I understand. I'm sure.
Yes.
Huh? Somebody online have a question?
No, sir.
All right, very good. So no go, so no bright. Make sure you know. When you get the real question, I'm gonna shut them up, you know. Oh, so nobody know the problem. All right, that's why I like it. Number 4, I gave you number 4 to do. I gave you number 4 to do. All right, let me see. I want to skip number 4 today. Because it's a topic called rates of change that we're gonna do. All right. I'm also gonna do solid geometry. So what do those topics? I come back to this one. All right. So let me skip over this one. Don't worry yourself. Yes, so yes, so borrow yes. We're also not doing number 3, but that is sets and construction. So we go to number 2. All right, so number 2 wants us first to solve this pure simultaneous equation, right? Why is that? Well, this can be eliminated easily because we already have 2y and -2y on them. So we need to add the 2 equations to get rid of the y. So we can use the elimination method. So 3x plus 2y equals 13 and x minus 2y equal -1. Just need to add the 2 equations right now. Let's add them. So if I add them, we're going to eliminate this. So the 3x and the x there, so it's 4x. These two wipe out each other. And then the 12 and the -1, 13 and the -1 is 12. Divided by this 4, we get x equals 3. That's an easy question. We're going to take x equals 3 and plug it back into the first one right there. So we can say, and 3 times 3 plus 2y equals 13. This 3 times 3 is 9, transpose the 9. We get 2y equals 13 minus 9. So 2y equals 4. And then we divide by the 2, we get y equals 2. So solution is 3, 2. Or you can say x equals 3, y equals 2. Easy question. Very good. Next part wants us to factorize these two things. So it's like the break up this quadratic first already. That's the difference of 2 squares, you know. So it's x squared minus 16, same as x squared minus 4 squared. So it becomes the difference of the numbers times the sum of the numbers. X minus 4, x plus 4, that is it. That's how you factorize the difference of 2 squares. Then we have this quadratic. 2x squared minus 3x plus 8x minus 12. Like it already split up for us. Highest common factor in these two terms is just x. Out of this, I'll have a 2x. Out of this, I'll have a -3. Let's try this is a factor over here first by putting it back first. 2x minus 3. Yes, it is. Get a 4. Divide this by -3, get a 4. If we divide this by this 2x, you get a 4 plus 4. So then this becomes a common factor. And you're adding these to add a common factor. So it becomes x plus 4 times 2x minus 3. That's this second one here. What go to that? Nice. Next part says, next part is just some simple arithmetic. It says, tickets for a football match are sold $30 each for adults, $15 each for children, or for a child. The company bought 28 tickets in total. All right, so let's write it down. Adult ticket is $30 each, and children ticket or child ticket is half as much, $15 each. So the total number of tickets bought is 28. It says if X of these tickets were for adults, write an expression for how many for children. So 28 tickets total, 28 total tickets, 28. Out of the 28, X is for adults. X adult tickets. And therefore, if it's X adult ticket, it must be 28 minus X children ticket, don't it? Agreed? Can I agree with that? If it's 28 tickets in total, and X of them is for adults, then 28 minus X must be the remainder, which is 28 minus X must be for the children, right? So number of tickets for children is 28 minus X. The amount spent for tickets for adults, and it's in terms of X, the one. This must be $30 times X, don't it? But I get that? That's $30 for one. And the amount spent for tickets for children must be number of tickets for children times 15, don't it? So that would be $15 times the number of tickets for children, which is 28 minus X. But I get that? Question says, show that the total amount spent for 28 tickets is this. Total amount spent for 28 tickets is this amount plus that amount, don't it? That's all? The amount for adults plus the amount for children. So total spent is equal to 30x plus 15 into 28 minus x. I working in dollar, put on the dollar sign, put on the dollar sign. This becomes 30x dollars plus, let's work this out now. 15 times 28 is how much? What is 15 times 28? 420. That's $420. And then you have 15 times minus x is minus 15x. Minus 15x dollars. This works out to this 30 minus this minus this 30 minus this 15 is 15. So you get 15x dollars plus this $420. And if you factorize the dollar sign, you're gonna get 15x plus 420 shown. That's what they told us to show right here. Then it says, given that the cost of a 28 tickets is $606, I said this equals 660, you know. 660 equal all of that, right? Right? First of all, part 3, it means that the total amount, which is 15x plus 420, is equal to 660. I left out the dollar sign. Right? Question says, calculate the number of adult tickets sold. So this question is asking us for X, number of adult tickets. You need to calculate X from this. So based on this, X is going to be 660. Take the 420 and carry it to one, subtract. get minus 420, and then take this 15 and divide it under here. Divided by 15. Whatever we get for that is the number of tickets sold for adults. Because X is the number of tickets sold to adults. But okay with that calculation? I'm getting 16. 16 adult tickets. Adult tickets. Question done. One more question. So now pop up. So where do I go? Eh? There's a ham and soil and cake. Oh man. Hey, not even 1.5 hours yet, you know. Yourself. One last question. Number 1. Number 1, part A says, using a calculator or otherwise, the exact value of this thing. Let me just get the calculator done. Not gonna complicate it. That is why I'm forcing you guys to get that kind of calculator, this textbook display. So you can type this in it exactly as it appears there on the paper because of questions like these. All right, you don't want the full calculator to make you get the wrong answer. Type it in there exactly as it is. Bracket, mixed number, 1 3/4, close bracket, and you square it, type it exactly as it is. Divided by 3.5, mixed number, 3.5. And it's as a fraction, right? As a fraction. So as a fraction, this is 7/8. So this equals 7/8. Then this one now, for the one answer in standard form. All right, so let's go for this one now. Clear? It is the square root within this one now, this one. It is the square root of 0.0529. And then out there we're adding 0.216. So it becomes equal to 0.446. But in standard form, you want the decimal point to be after the first non-zero digit. You want decimal point to be here. So to get the decimal point there, you have to multiply by a 10 to the 1. To balance out back that multiplication by 10 to the 1, you have to multiply by 10 to the minus 1. So the final result will be 4.46 times 10 to the minus 1. Put another way, say guys, it's not complicated. Small numbers like these decimals, they carry negative powers. A small number. Large numbers, tens and hundreds and so on, they carry positive powers on 10. Simple. Right? But to do this calculation, let's say you have that and you want to show a calculation for it. Let me do it down here. So you have 0.446. I want to convert that to standard form. You need this decimal point to come right here. You bring the decimal point there, you would multiply this number by 10 to the power 1. 1 meaning that I move it one place to the right. To cancel out this multiplication by 10 to the 1, I multiply by 10 to the minus 1. Multiply by 10 to the 1 and multiply by 10 to the minus 1. Negate each other. The calculation that I've done here will move the decimal point for us and leave this as a part of the answer. right? And so it will become this after the decimal point is moved. 4.46. The decimal point is moved by this calculation in the bracket. So you multiply that by 10 to the minus 1. So it's like a process to do it. But it's simple. If it's number very small, the negative power. Number large is positive power. Right? So whatever number of places you have to move the decimal point to get it. All right, let's say instead I had 446. I'm going to it in standard form. Right now, the decimal point is here at the end of the number. It's a whole number, the decimal point is at the end. Right? But that's a large number, so the final result must be 10 to some positive power. That's a big number. If we move the decimal point 2 places to get it where I want it, 1, 2. That tells me that when I move the decimal point here and put where I want it, the number becomes 4.46. But because the number is a big number, it has to be 10 squared. 10 squared. The number must have a positive power like that. That's a big number. So that must be the answer. You get me? And then with this now, you can see if this would move by the decimal point and put it back at the end. Yes, it would. But this 10 times, this 10 to this times 10 squared means the decimal point will move 2 places to the right to get back the original number. But that is it. All right, enough of that. The answer for this is that one. Next part now is what do you call it again? Salary something. Pay bill and so on. Let's wait for it again. I don't remember right now. It's slipping me. Payroll. Question says the typist is paid a basic wage of $22.50 per hour for a 40-hour week. So this is what she works as a regular pay. Regular pay, she works 40 hours in a week, maybe 5 days, 8 hours each day, and she's paid this per hour. It says calculate the type is basic pay. That's a pay before she earn any overtime or anything like that, or any deductions or any additions. So the basic is going to be 40 hours times the hourly rate of $22.50. The basic hourly rate. The basic hourly rate is 22 times 50, 22.50, and then you multiply that by 40 hours. All right, so I'm just calculating here on my phone. It's 40 times 22.5, $900. So $900 is our basic weekly wage in 2012. We're now in 2024. We're into 2025. All right? That's the answer for this part. $900 is our basic pay without overtime. It says overtime is paid at 1.5 times the basic rate. So you're going to multiply this hourly rate by 1.5. So see here now, the OT rate for part 2, the OT rate, the time for overtime hours, is 1.5 times the basic rate of $22.50. That's going to tell you the rate. So it's 1.5 times that. So it becomes 1.5 times 22.5, that's 33.75. 33.75 per hour. OT rate per hour. Per OT hour. So for every overtime hour that she does, that's what she gets. Every hour of overtime, she gets this amount. All right. So the question says, calculate the overtime wage for 1 hour. This is it, you know. That is it. We just work it out on there. So this works out to be 33.75 for 1 hour of overtime work. 33.75. Then it says, to earn some extra money, the typist decided to work some overtime. 2 options. I guess there are 2 options, right? She's going to work overtime. Let's see what she does in the first option. Right here. It says, calculate the wage she would earn for overtime. That's overtime she wants to know. If she worked a total of 52 hours. So if you work 52 hours, you have to take out 40 regular. Means you work 12 hours overtime. I multiply that 12 hours by the overtime rate. You see that? All right. So for part 1, part 3, sorry. OT hours will be equal to 52 minus 40, which is 12. So we're working 12 hours overtime. And so the overtime pay, that's what they want to know, the total pay, they want the overtime pay. So the OT pay will be equal to 12 times the OT rate of 33.75. That's what they're working on. 12 times the overtime rate. 12 hours overtime times the overtime rate. How much money she get for overtime? 12 times 33.75. $405 overtime pay she will get. She will get $900 for the 40 hours, and they get an additional $405 for the overtime hours. All right. Part 4, the number of overtime hours she must work during a given week in order to earn a total wage of this. So if you're gonna earn a total wage of this, and you want to find the overtime hours, you have to find the overtime pay that she gets. So you subtract the 900, and you divide that by the overtime rate to know how much hours she works. So the OT pay in part 4 will be equal to the total pay of 1,440 minus the overtime pay of 900. That's the overtime pay we calculated by doing that subtraction. All right. Bang, 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 bang. What I work out to, guys? Work it out. 540. So she's earning $540 overtime money. But the rate at which you earn this money was $33.75 per hour. So to know the total overtime hours, you know, need to divide this by the $33.75. So the OT hours that you work has to be the OTP, which is 540, divided by the overtime rate, which is $33.75. That's going to tell us what the overtime hours is. So dividing this 540 now by the 33.75, I'm getting 16 hours. 16 hours overtime. So work 16 hours of overtime. So that week should have worked 56 hours. 40 hours regular and 16 hours overtime to earn that money. So I could have asked the total hours we should work that week. Right? But I wanted the overtime hours, the number of overtime hours she must work. But I wanted the total hours she must work, I put 56. I should have worked the 40 hours regular and the 16 hours overtime. But that is it, guys. Question done. So you know what time it is. I'm going to send another paper in the group. I must do it before tomorrow's class. So tomorrow's class is exclusive online for everybody. All right? I won't bother to ask anybody to come out so close to Christmas. The parents must want you to stay home and help clean up the house and paint and all of that. And cook some of the food and the ham and the cake and the sorrel. No class Wednesday, no class Thursday. Giving you a break. No class Wednesday, no class Thursday. That is not to say that I won't send work. I send work for you to do. I send some work for you to do. Yes. Yes. More maths equals better maths. Yes. Jesus will love you for it. All right, guys. So that is it. So remember, no face-to-face tomorrow, guys. Everything online tomorrow. Join online tomorrow. It's at 4 p.m., by the way. 4 o'clock tomorrow. 4 o'clock tomorrow online. Any change, I'll let you know. But for now, it's 4 o'clock tomorrow online. Okay. Bye, everybody. Bye, online students.
Bye.
All right. See you online tomorrow, 4 p.m. Tell it to your friend and neighbor, 4 p.m. tomorrow online. All right, bye. I'm gonna end it now. What's your classmate? Huh? What's your classmate? You try to tell her don't ramp now. Don't joke about the thing. All right.